Hi, this is Nathan Tintle. In this Learning Goal video, we will talk about how to apply the 3S strategy to the Swimming with Dolphins dataset. Remember the 3S strategy: statistic, simulate, strength of evidence. The statistic for this study is the difference in proportions, 0.47. To simulate, we will use card shuffling and dealing, and to assess the strength of evidence, we'll ask how frequently does the observed statistic, 0.47, or more extreme, occur in our simulated data. We can compute a p-value that way, or we could compute a standardized statistic. Let's see this step by step. The simulation shown here is 1,000 different values of the difference in proportions that could have happened if the null hypothesis is true. You'll notice that this is a bell-shaped curve centered at 0. 0 represents the difference in proportions if the null hypothesis was true. We would expect to see no difference in the proportions. Of course, just by chance, you will see differences in proportions, and this graph represents that values between 0.4 and negative 0.4 occur fairly frequently just by chance. To evaluate the strength of evidence, we can say, well, how often did we get a value like the one we had in our study just by chance? In this case, we can see that 0.467, which was the difference in the group proportions in the Swimming with Dolphins study, rarely happens by chance. In fact, the p-value, the probability of getting 0.467 or larger, is 0.02. This means that we have strong evidence of a higher chance of improvement when swimming with dolphins versus the control group. A couple of words of caution. When doing simulations comparing to group proportions, the rules about one-sided and two-sided are very similar to what we've seen before. If the research question asks about a difference between the groups, you're doing a two-sided test. If the research question says, is this group bigger than the other, you'll do a one-sided test. Some students wonder, well, what about other statistics? We've talked about the relative risk before. Could I use the relative risk here? Or could I just use one of the cell counts in that two-way table? Actually, you can, and in this case, you'll get the exact same p-value. Mathematically, if you only have one number in your two-way table, that allows you to figure out what the rest of the numbers in the table are. For that reason, whether you use the difference in counts, the relative risk, or one of the cell counts, you'll get the same p-value for a two-way table. That isn't necessarily the case when we look at larger tables when we have categorical variables with multiple categories.